Hello everyone and welcome to EvolkAI, a machine learning community for machine learning enthusiasts. Now today we will be learning about Gradient Boosting Classifier. Gradient Boosting Classifier. It is a powerful technique in a machine learning that combines multiple weak or simple models to create a strong and accurate classifier. To understand gradient boosting, let's imagine you are trying to solve a difficult problem like finding a hidden treasure in a large area. Now, instead of searching for treasure all by yourself, you can decide to seek help from a group of friends. Each friend has their own strengths and weaknesses. Some may be good at searching in open areas, while others may be better at finding hidden spots. In gradient boosting, we start with a weak or simple model called a decision tree, which is like having one friend with limited searching skills. This initial decision tree makes some predictions, but it is likely to be inaccurate. To improve the accuracy, we focus on instances where the initial decision tree make mistakes. We pay more attention to these instances and assign higher weights to them, making them more important for the next model we'll build. Now we bring in a second decision tree which focuses on the area where the first hidden tree struggled. Let me just give you the diagram. So this is the diagram. Okay. This new another new tree formed will help to correct the mistakes made by the first one. However, it might not be perfect either. We repeat this process, gradually adding more decision trees, each one correcting the mistakes of the previous tree. This iterative process continues until we have a strong ensemble of decision trees that collectively make accurate predictions. Each new decision tree is built by finding the best way to improve upon the mistakes of previous trees. This is where the term gradient comes in. It represents the direction of improvement, similar to how you adjust your search strategy based on the feedback from your friend. Now, finally, we want to make predictions on new unseen data. We combine the predictions of all the decision tree in the ensemble. The combined predictions are weighted based on the performance of each decision tree, giving more weights to more accurate trees. Okay, so now moving to the practical part. Okay, so now first we will start by importing the pandas library, and we will read the dataset using the read CSV function, and we will get all the data information using the info function. Then we will assign all the columns that we have to take from the user and store it in features variable, and the prediction class will be predicting column will be stored in prediction class variable. Their values will be stored in X, and for the features, and for prediction class the values will be stored in Y. X will have all the data that our user will give us as the input, and Y that it will get as output from the machine learning model. Now this is the training and testing part. Here we have to train here we have to split the data into training and testing part. Here we have assigned test size as 0.30, which is an ideal, as we have already discussed in our earlier videos, that the testing part should always be less and training part should always be more. So here the training and testing part is divided into the ratio of 7 is to 3. That is 70% is the training part and 30% is the training part. More that a model will be trained, more accurately it will predict the results. Okay, so now here we will check the shapes of the data to check if the test split has done its work correctly or not. Okay, so now we have reached the most important part of our presentation. So here we will import gradient boosting classifier from ensemble library and assign it to a variable classifier. Now we'll fit this model or the classifier with the training data, that is X train and Y train, and we'll assign a new variable Y pred where we will make predictions on X test using the model. Now from sklearn.matrix, we will use the accuracy score function and predict the accuracy using ytest and ypred variables. Now every time the ytest and ypred will be same, the accuracy will increase, and every time they will be different, the accuracy will decrease. So since this is a boosting classifier, the accuracy for these type of classifiers are pretty much high every time. So the accuracy we have attained here is 93.33%. Now we will move to the Visual Studios to get a practical implementation of what we have done here. Okay, so now we have come to our Visual Studio. So here I'll be explaining the code of Gradient Boosting Classifier. So I'll quickly run all this code snippets and I'll explain you the code line by line. So here first we have imported the pandas library, and then using the rate CSV function we have read this iris dataset. Now, using the info, we have collected all the informations. That is, what is the range index? That is, how many entries are there? What are the different columns? If the column has null value or not? The data types and the memory usage. Now we have defined the feature and prediction class here. The feature class has the input columns and prediction class has the predicting column that our model will give us as the output. Now their corresponding values we have stored in x and y. For like features value we have stored in x, and prediction class value we have stored in y. Now from sklearn.model selection we will import rain test split that will help us split the data set into 70 to 30 ratio, that is in the training part and testing part. And we will print the shapes of the testing and training part to get a clear vision of if the data has been splitted properly or not. So here we can see that the training data is more and the testing data is less. So here we can say that the split has been done properly. Now from sklearn.ensemble we will import gradient boosting classifier. Now since we have discussed this, the gradient boosting classifier works on small randomly defined classifier. So the same process will be done here, and we will assign this model into classifier variable and fit this variable with xtrain and ytrain data, and we will create a new variable ypred which will predict the values based on x test using the model. Now we will import metrics from sklearn, and using the ytest and ypred variable we will predict the accuracy on this model. Now here we have got an accuracy of 95.55. Since this is a simpler data set, we have achieved this accuracy, but for a complex data set we will be achieving a low accuracy. But if we compare it to other classifiers, other machine learning models, it will usually be higher. So this was it for the coding part. Now we will be moving to the conclusion part and conclude the video. Okay, so now we have reached the conclusion part. So we can say that the gradient boosting classifier is a powerful algorithm widely used in various applications such as click-through rate prediction, fraud detection, and recommendation systems. Its main advantage lies in the ability to handle complex data and capture intricate relationships. Gradient boosting excels in improving model performance by iteratively minimizing errors and learning from the mistakes of previous iterations. Additionally, it can handle different types of data and automatically handle missing values. However, gradient boosting has some drawbacks. It can be computationally expensive, requiring significant computational resources and long training times compared to other algorithms. Overfitting can also occur if the algorithm is not properly tuned or if the dataset is noisy. Furthermore, interpreting the results and understanding the impact of individual features may be challenging due to an ensemble nature of the model. Okay, so this was it for the video. Thank you for watching and happy learning.